Hello everyone, in this video we will talk about greatest common factor, common factorings, simple difference of square, factoring simple trinomials, and simple special products. So we will begin with common factorings. Okay, for example, we are going to identify the greatest common factor and factor out the greatest common factor of the following expressions. So before we get into finding the term representing the greatest common factor for each of this term, what we are going to take a look at is we concentrate on the numbers first. Okay, so the number is negative 34, number is positive 12 or negative 6, or I should say the coefficient of all of this term. So negative 34, positive 12, and negative 6, you need to find a number that divides evenly into each of this number, and that number has to be the greatest. Alright, so notice that negative 34, positive 12, negative 6, they are even number. So number 2 would be the one. Okay, so 2 divide into negative 6 evenly. 2 divide evenly into 12. 2 also divide evenly into negative 34. Let's say you said, how about I try 3? Because 3 is greater than 2. Okay, so 3 divide evenly into 6. 3 divide evenly into 12. But 3 does not divide evenly into negative 34. Therefore, the greatest common factor in this case is positive 2. Okay, so the greatest common factors for all of this coefficient is positive 2. What about the term? What about the variables here? We have the power of x to the 6, x to the 5, and x squared. So you are going to pick the one with the lowest exponent. So the greatest common factor in this case, identified as 2x squared. Okay, so what I'm going to do is I'm going to explain to everyone the step behind factoring. So after you find these greatest common factors, it means that you are going to write it outside the brackets. Okay, so greatest common factors mean basically if you want to factor this, you are going to divide this 2x squared into each of this term. Alright, okay. So I am going to write that as I divide this greatest common factor into each of this term. And after I finish this, I'm going to review a formulas. Okay, so if you have 2 power divide into each other, you keep the base the same and then you subtract the exponent. Okay, so there it is. Okay, so before I get back to this, I would like to show everyone something very simple on the side. Okay, so let's say we have 4x squared plus x, and I ask you to factor this. So before we do this automatically, you immediately tell me that, oh, I know right away the common factor would be x. Okay, so and then you said, okay, I pull x outside the bracket. Inside the bracket, I should have 4x plus 1. Okay, so we do this automatically, right? Automatically because it's so simple for us to recognize that if you take x times 4x, you end up with 4x squared. You take x times 1, you end up with x again. But the step behind this is this. The step behind is, in fact, you are taking x outside the bracket, but you have to divide x into each of this term inside the brackets. Because it is an expression. Basically, you multiply this entire expression by x, therefore you have to divide it by x, okay, to keep the expression the same. So now you see x is the common factor, and that cancel out, so you have 4x left, and that cancel out, you have 1 left. Okay, so this is just something that I want to remind everyone on the side, that we have done common factoring for a long time, and we often dealt with this simple expression like that, and we forget the step behind the greatest common factors. Okay, so greatest common factor is you pull out that factor, then you divide that greatest common factor into each of this term. So this is called common factoring. So I did the same here. So now I am going to write 2x squared, and inside the bracket you are going to divide. Okay, so negative 34 divided by 2, I should have negative 17 left. Okay, now x to the exponent 6 divided by x to the exponent 2, I should have x to the 6 minus 2, so I should have x to the 4. So right here I write x to the exponent 4. So the next term, you are taking 12 divided by 2, so you have 6 left. Okay, so this one, similar, you take 5, subtract 2, so your exponent should be 3. Now, the next step is that cancel out completely. 6 divided by 2, you should end up with negative 3 as the final answer. Alright, okay, so now we already performed the step called common factoring. So common factoring is you are multiplying this expression by the common factors. Therefore, you have to divide that same common factor into each of these terms. Okay, so it seemed complicated that I explained to everyone the step behind the common factoring. The reason I'm doing that is because it will relate to the next example that we are going to work with. Okay, because sometimes your common factor is not obvious. Okay, so this one is very simple. So I'm going to move on to the next example, and I am going to just to remind everyone, is that just a simple example, okay, to demonstrate a step behind common factoring. So don't forget, we have done it for a long time, or many times already. So it's so simple that we could recognize it right away. However, there will be expression that the common factor is not obvious, and we have to go back and rely on these steps. Alright, so here it is. This is the exact example that I would like everyone to take a look at. Okay, so I ask you to factor the following. Okay, so you see that you have x squared multiplied by 2y minus 3 plus y squared multiplied by 3 minus 2y. So these two terms inside this bracket is like almost similar to each other. The difference is I have 2y minus 3, here I have 3 minus 2y. So x squared, y squared, there isn't any common factor for these two, but there must be something here that I can try in order to pull out my common factor. So what I'm going to do first is I am going to write 2y minus 3, but for this part I am going to factor out the minus 1. Okay, so if you factor out the minus 1, so we don't need to go back to apply the step behind common factoring. So if you factor out minus 1, you end up with negative 3 in the bracket, right? Okay, and then you end up with positive 2y inside the bracket. So note that I can simplify this a little bit more. Okay, so you take negative 1, you multiply by positive y squared, so you end up with negative y squared. Okay, and you rearrange this term so that you write 2y minus 3. Okay, so now you see that you have this, and these are the common factor. So the common factor. Now, I am going to write the step behind my common factoring. So common factoring is you identify your common factors. So I will write common factor is 2y minus 3. Okay, so basically, like I said, you multiply this 2y minus 3 into the entire expression that you have as the original questions. Okay, then you are going to multiply this with this, but in order for you to have the same expression again, you need to divide the common factor into each of these terms. So I have x squared 2y minus 3, so I divide it by 2y minus 3 plus y squared, but in this case it becomes the negative now. Alright, so negative because I have it negative here. So here is my 2y minus 3, the whole thing divided by 2y minus 3. Now you can see that this and this cancel out, that and that cancel out. What we have left inside the bracket is 2y minus 3 multiplied by x squared minus y squared. Okay, so but we need to factor completely. Okay, so factor completely. That means we see whatever we can factor, then we must factor. So this in fact is the difference of square. So what is the formulas for the difference of square? Formulas for the difference of square is this. A squared minus b squared will be the product of a minus b, a plus b. Or b plus a, it's the same thing, okay? But I should just write that a minus b, a plus b. So in this case, you should have 2y minus 3 multiplied by x minus y multiplied by x plus y. Alright, so this is the final answer. You factor out completely. Okay, so let's recap what we have done. Okay, so factor the following. Okay, so you have x squared and y squared. There isn't any common factor for these two terms, for these two variables, x squared and y squared. But for the terms itself, this term and this term, 2y minus 3, and then here you have 3 minus 2y. They are similar to each other in the way that you want to make them the same by factoring out the minus 1. Okay, so it's a bit tricky here that we have to realize that we have to factor out the minus 1. As soon as you factor out the minus 1, this turns into minus 3, this turns into plus 2y. Now multiply the minus 1 to the y square. Inside the bracket you left with this term, but you will rearrange it so that it will match with the previous term. So now you can see that your common factor would be 2y minus 3. Then factor out 2y minus 3, divide that common factor into each of the terms inside the bracket. You can see that they are cancelled out, and what you have left with this, and this happen to fall into the difference of square. Therefore, you have to do one more step by factor this expression out fully. Alright, okay, so now from this point on, we cannot factor any further, so we have to leave the expression like that as the final answer. Alright, so let's move on to the difference of square. So I introduced the difference of square for everyone here. So let's continue with the difference of square factoring some expression just involving the difference of square. Okay, so whenever you factor, you have to factor, and you have a square, subtract another number or another square, then you should apply these formulas. Okay, so for example, 3a, this one is quite simple. Okay, so if you want to recognize 289, is it a perfect square? If you want to recognize it, or you want to make sure, I can show you a trick that you take the square root of 289, and square root of 289 is actually 17. So obviously, this one you have x squared minus 17 squared, right? Okay, so here it's very simple, just x minus 17, x plus 17. And we are done. Okay, simple like that. Now, this is a little bit more complicated that I need everyone to review one formulas before we get into the example 3b. Okay, so that formulas is like this. Exponent. Okay, so if you have a power raised to an exponent, it means that you need to multiply the two exponents. Okay, so this is a power a raised to exponent m. All of this power raised to exponent n. It means that you must multiply the two exponents. And one more thing, that if you have a times b inside a bracket, you raise this to the exponent n, then you have to raise each of this to the exponent n. Okay, so that you raise this to exponent n, and b is raised to exponent n. Okay, so these two formulas are very important for us to apply to our example 3b so that we can factor. Okay, so now 9x squared. 9 is a perfect square, right? Perfect square means that you can get a number and you square that number equal to 9. So in this case, I will have 3 squared x squared. So I write it like that, step by step. Okay, now 16 is also a perfect square, which is 4 squared y squared. Okay, now I'm going to apply these formulas. Because before I can get my a squared minus b squared equal to a minus b, a plus b, I have to identify what a is and what b is. Okay, so in this case, now I can write this as 3x in the bracket, all of it square, because I apply these formulas. Okay, now I will write 4y, all of it to the exponent square. So now you see you identify your a and you identify your b. So a would be 3x, b would be 4y. So now I will write this as a minus b, okay, multiplied by a plus b. So in this case, I should have 3x minus 4y in the bracket multiplied by 3x plus 4y. Okay, so we complete this question. And be careful, we need to review the formula for the exponents. And remember this exponent right here. Alright, okay. So now the next step is to, I am going to ask everyone to do this for me. Okay. If you are not sure if you got it correct or incorrect, let's review the step that you can multiply them back in. Then you can see whether or not you get the original expression back. Okay, so 9x squared subtract 16y squared. So in this case, what I'm going to do is I'm going to check my answer. Okay, check my answer by, I will expand. Okay, expand by multiply term with that. So I got, so take a look at this, right? This should be the x, I'm sorry. Okay, so now what we have is we have 9x squared plus 12xy subtract 12y y times x is the same as xy, and subtract 16y squared. Now you see you can cancel the two middle term, and what you have left is 9x squared subtract 16y squared as the result, right? All right. Okay. So I would like everyone to take a look at this example. All right. So this example is 5x squared subtract 20y squared. And make a comparison between the example 3b and example 3c. So you see here, I was telling everyone that you look for a perfect square. You see right here, perfect square. For 9 is 3 square. Perfect square for 16 is 4. And then you write 4 square. But for this example, 5 is not a perfect square, and 20 is not a perfect square. Then what should we do in this case? So what I recommend everyone to try is you try common factor first. Okay, so with common factors, eventually you may find that there's a perfect square will reveal itself. So the common factor in this case would be 5 for the coefficient. So if I take 5 outside the bracket, inside the first term, I left with x squared. The second term, I should left with 4y squared, right? Okay. Everyone agrees, right? So 5 pull out of the brackets. Take 5 divide into this. I should just have x squared left. Take 5 divide into negative 20y squared. I should have negative 4y squared. And we need to apply the difference of square here. Okay, like then again, step by step, I will write this as 2 square y square. Okay, I'm writing it like this so that I can combine this and make that as 2y, all of it in the bracket square, and then close the bracket. Okay, because I'm applying these formulas. So this should be the end. All right. Okay. So now what is your A? A will be your this x. B is 2y. Then I can write my factor as 5x minus 2y multiplied by x plus 2y. All right. And we are done. Okay. Factor fully. So what about example D? For this example, 3 again is not a perfect square. 27 is not a perfect square, but y4, you see that, is a perfect square. Okay, because y to the exponent 4, you can pull a square out of it by writing it as, I write it on the side for everyone to see. Okay, so I can raise that to the exponent 2. Okay, because I'm practicing these formulas, if I raise a power to the exponent and I multiply the two exponents. So in this case, I will try common factor first. Okay, try common factor first. If I pull out the 3, I have y4 left in the bracket, and here I should get 9. Now you see 9 is a perfect square. So eventually, after you've done the step of common factoring, the perfect square will reveal itself. So now I am going to write this as y square, all of it square, and 3 square. Okay, you need to match that formulas with the perfect square. Okay, a plus b, right? Okay, so in this case, what do you have? Your a will be y squared. Your b is your 3. Therefore, I am going to have the factor as y squared minus 3 multiplied by y squared plus 3. Okay, so don't forget to make sure that you include the square. Y squared is your a, because all of this already raised to exponent 2. You see, you try to match this. You see why I have y squared as y squared minus 3 and y squared plus 3. Alright, okay, so I think I will stop my video right here, and I will continue with the factoring trinomials in the next video, because in factoring trinomials we are going to deal with 2 cases. Okay, so before I end the video, I would like to recap what I have done with the difference of square, factoring using difference of square, because sometimes they won't tell us that apply the difference of square formula in order to factor this. Okay, so when you factors, there's so many different type of question that they put together, so you have to recognize what method to use. Okay, so basically what we do here is we are just applying common factoring. But here, if you have just 2 terms, okay, you have 2 terms and you have a square in it, that means you are going to factors and apply the difference of square. Okay, so you have 2 terms right here and you have square in it. Chances are you must apply the difference of square. Okay, and sometime before you can apply the difference of square, you must apply the common factor first, so that the perfect square will reveal itself for you to apply the difference of square. And the same thing here, you need to perform the common factoring step. The common factor is 3, and you see that the perfect square will reveal itself. Perfect square for 9 is 3, and don't forget y squared, all of it to the exponent 2 is y to the exponent 4. And I mentioned earlier that y to the exponent 4 is also a perfect square, because y squared, all of it square, will give you y to the exponent 4. And writing it like this, using these formulas, you can recognize that your a is the full y to the exponent 2. Okay, so at this point, we cannot factor any further. Alright, thank you everyone. The next video will be factoring trinomials. Okay, and we also talk about the special product as well. Alright, thank you everyone.